Welcome to Usability and Human Factors Usability Evaluation Methods. This is Lecture B. At the end of this lecture, students will be able to 1. Perform the steps needed to conduct a cognitive walkthrough. 2. Describe the appropriate usability testing, specifically how to select or design appropriate tasks for a usability test. One of the objectives is to understand how to develop a protocol for usability testing and undertake various kinds of analysis. In addition, one should be able to describe the usability testing environment, including the required equipment, logistics, and materials. The Cognitive Walkthrough, or CW, is an alternative usability inspection method developed by Polson and colleagues. It's richly steeped in cognitive theory, most notably Don Norman's theory of action. The analysis takes the form of a cognitive task analysis, or CTA. In a minute or so, we'll go through the procedure and then we will illustrate this method with a couple of examples. Criteria of the analysis focuses on cognitive processes needed to perform tasks. It involves identifying sequences of actions and subgoals to successfully complete a task and assigning causes to potential usability problems. The key question is whether the cues provided by the interface are sufficient to perform the task. The alternative is that the user will have to wander through a more complex space, expending greater time, effort, and cognitive resources. The Cognitive Task Analysis, or CTA, is a family of methods for describing the knowledge and strategies required for task performance. It involves a hierarchical decomposition or breakdown of goals and component tasks. For example, performing a Google search can involve the following two components at minimum. 1. Selecting key terms, and 2. Evaluating the results of the search. Each of these components has distinct goal-action structures. This should become much clearer in a couple of moments. Why do we do a cognitive task analysis? There's a wide range of reasons for undertaking such an analysis. For example, you can develop a theory or model of competent performance for a task or classes of tasks. Using the example of a Google search, there is a set of skills and knowledge needed to do a Google search in a domain such as healthcare. The CTA can help us derive a model of how to do that competently. The cognitive task analysis can also be used as a means to develop training materials. Although usability inspection methods are standalone methods, they can be used in concert with usability testing. The cognitive walkthrough is a very good precursor to usability testing. You can use the analysis to develop a set of tasks to give to users. One can also differentiate between complex and less complex tasks. One common and relatively simple measure of complexity is the number of steps or actions needed to complete a task. There are 3 essential steps to performing a cognitive walkthrough. There are a number of decisions to be made prior to undertaking the analysis. This begins by identifying the inputs to the cognitive walkthrough, beginning with a selection of representative tasks. The cognitive walkthrough is a relatively time-consuming process, and it's important to judiciously select representative tasks of interest. For example, an electronic health record system may support hundreds of different tasks. But these tasks can be grouped into a relatively small, finite set of tasks, including data retrieval, data entry, and ordering of tests. You might select 2 or 3 tasks from these sets of tasks. It's important to keep a target population in mind. Will the target population be relatively sophisticated computer users, or will they include some novices? Will older adults also be expected to use the system? Granularity of analysis is an important issue to address. You might choose to do a very fine-grained analysis where the focus is on the keystroke level, for example. Alternatively, you might choose to conduct a higher-level analysis and focus on the types of errors in data entry. The less granular analysis may prove to be more useful in most practical contexts. It requires less time and expertise to analyze goals and actions at a higher level of abstraction. The walkthrough process involves a kind of hand simulation of users' cognitive processes for successfully executing an action sequence to complete a task. The analyst steps through each action and specifies 1. Goal structure for each step, 2. Behavior of the interface and its effect on the user, 3. Actions that could be difficult to execute, 4. Source of potential problems. As mentioned previously, the overall objectives are to determine whether a user with a certain degree of knowledge can perform the tasks that the system is intended to support. If not, can they readily learn to use the system? Learnability is an important issue when dealing with systems such as EHRs. Such systems necessitate a certain learning curve, and some are much easier to learn than other ones. The third phase is to explain the sources of potential problems. For example, does the system provide sufficient feedback after every action? Or are there potential sources of confusion? Are the transitions between subtasks abrupt and confusing, or are they handled gracefully, keeping the user informed? It's also helpful to draw on Nielsen's principles to organize one's findings of potential problems. Our first example is using an ATM or automated teller machine. This slide provides the input to the cognitive walkthrough. ATMs support a handful of tasks such as obtaining cash, depositing checks, and paying bills. To execute one of these tasks, you need to carry out a set of steps. ATMs are walk-and-use technologies. No training is needed. Almost everyone knows how to use one at this point in time. This is a partial walkthrough of an ATM. The task and the top-level goal is to obtain $80 in cash from your checking account. There are a total of 11 actions. The first action is to enter your card, and the system's response is to prompt you to enter your personal identification number, PIN. Subsequently, the interface presents you with a set of dialog screens in which you are expected to make certain choices. As you move through the actions in the walkthrough, you move closer to completing the top-level goal of obtaining $80 from your checking account. The interactions are rather straightforward. Each screen reflects a goal action structure with particular sub-goals, necessitating certain action sequence as laid out in the walkthrough to accomplish the subtask. By the 11th action, the user should be entering $80 on the numeric keypad and selecting Correct from the offered options. We conducted a cognitive walkthrough of a commercial glucose meter. The cognitive walkthrough can be used to evaluate any kind of device. A detailed but partial walkthrough is illustrated over the course of the next 3 slides. The task was to measure glucose. These slides shows 3 sub-goals, beginning with the goal of beginning a measurement. Each top-level sub-goal, such as begin measurement, names a goal action structure involving one or more actions followed by a system response. Although this is a very basic task, there are quite a few steps, and the process is surprisingly complex. The sub-goals on this page continue to involve preparation to take the measurement. The system response of the flashing test strip at sub-goal 9 signals that the device is ready to take the measurement. At sub-goal 12, the test result becomes available to the user. Altogether, this is the most basic of tasks. It necessitated 14 sub-goals, 16 actions, and 5 device screen transitions. We also identified a handful of problems that may make taking the test or interpreting the results difficult for some users. It should be noted that this is an older glucose meter, and more modern ones may require fewer steps. However, when you unpack a task into goals and actions, it becomes transparent that something that seems simple is actually more complex and may present challenges for some users. The focus of this work was on low literacy older adults. The final method to consider is usability testing. Usability testing refers to a class of methods for collecting empirical data from representative users performing representative tasks. This is widely believed to be the gold standard, in other words, the best available method for usability evaluation. The usability inspection methods involve the judgments and speculations of analysts. Interviews, focus groups, and questionnaires are either subjective or involve self-reports. Usability testing provides hardcore evidence as to the nature of difficulties that users encounter when interacting with a system. We don't wish to disparage the other methods. All of the evaluation methods are useful. In addition, usability testing is the most time-consuming and costly of all of the methods. Some sort of video capture of users performing the tasks is typical. The Think-Aloud Protocol is a method broadly used in cognitive research as well as in usability testing. The user is asked to verbalize his or her thoughts while performing a task. They are expected to report the contents of their working memory, basically whatever comes to mind as they perform the task. The user is discouraged from engaging in self-analysis, for example, commenting on their strategies. The session is audio and/or video recorded. The transcript of the Think-Aloud protocol is coordinated with video analysis and provides a rather complete picture characterizing the nature of the interaction. The selection of users for usability testing should mirror the overall population of users to the extent possible. For example, if you're testing a glucose meter but don't include older adults in your sample, then you're discounting about 40% of the population who are likely to use the device. Usability testing involves in-depth testing with a small number of subjects. The heuristic is that a test can be perfectly valid with as few as 5 or 6 subjects. In addition, 5 or 6 subjects may find upwards of 80% of the usability problems. A typical usability testing study will involve 5 to 10 subjects. This small number makes it difficult to get a fully representative sample. Convenient samples are very enticing. For example, they may include the most enthusiastic users. However, they are not likely to be representative of the overall population of users. This may lead to skewed results and lead to wrong conclusions, such as the system has relatively few usability problems. The test plan includes a crystallization of your objectives. What tasks are most important to test? It is advisable that a testing session not last longer than an hour, as participants begin to get fatigued and frustrated. One also needs to select a sequence of tasks. Sometimes the order is unimportant. A general heuristic is to begin with the simpler tasks and progress to the more complex ones. If a subject is unable to complete an easier task, there's no reason to give him or her a complex task that you know will result in failure. What is the proper role of a researcher in a test situation? If your subjects are sufficiently skilled, then it is advisable not to interfere too much. Sometimes the role is regulated to encouraging the subject to think aloud. If a subject experiences difficulty with the task, then it's entirely reasonable to offer some assistance. We can't learn too much about the usability of a system if users can't even begin to complete the task. The heuristic is to provide as much guidance as necessary, but no more than necessary. Most usability studies are conducted in a lab setting. Sometimes that's just an office of the investigator. Field usability testing can be rather challenging, but very informative. You can study users in their naturalistic setting, whether it's in a clinic or in a patient's home. Not too long ago, field usability testing was a difficult process involving a lot of technology. This typically included a video camera to capture the user and one to capture the screens. This often required the use of an analog to digital converter since it's very difficult to directly video record a screen. However, there are now video capture software programs that can easily do the work of this technology. This means one of two things. You bring a laptop to the field setting and you use it for the purpose of usability testing. The alternative is to install the software on a computer on site. This presents a range of problems from securing permission to system conflicts that make the process all that more difficult. It may be especially challenging securing permission for installing software on a system that is used for viewing clinical data. There are a number of programs that support video capture and video analysis. Morae by TechSmith is one of the best. The software provides a video of all screen activity. It can also capture the user via a webcam, which can also record the Think-Aloud protocol. Such video-analytic software can greatly enhance and expedite the process of usability testing. This is a screenshot of the Morae Manager, which is a powerful video analysis tool. A project consists of a set of users or usability sessions. These sessions can be broken down into a series of tasks and subjected to further analysis, such as the coding of problem types. The analytic tools log a wide range of events and system interactions, including mouse clicks, keystrokes, text entries, web page changes, and Windows dialog events. We can compare performance of subjects across the same set of tasks. If a task resulted in performance problems and user errors, required numerous mouse clicks, and longer than expected periods of time, then we know that there are usability problems. We can further scrutinize tasks at very fine levels of granularity to diagnose potential problems. A transcript includes the transcribed Think-Aloud Protocol, which then needs to be synced with the video. A transcript would typically be organized by task and time. The transcript should include timestamps every 30 seconds or so. This serves to structure and index task performance. There is a variety of video transcription software available, such as InkScribe, to assist with this task. Video analysis can be performed at varying levels of granularity. At the most basic level, analysts may identify, categorize, and quantify usability problems. A macro analysis involves an analysis of dialogue or the Think-Aloud protocol. Microanalysis is a much more fine-grained analysis and is very time-intensive. This latter analysis would be used to answer research questions and is not likely to be used by usability analysts. The most basic level can be quite informative and will likely suffice for most purposes. The macro analysis can provide greater diagnosticity in analyzing potential problems. As suggested, although a microanalysis can yield substantial insights into usability problems and user competencies, it is mostly a tool for researchers. This is a transcript of an older adult performing a set of tasks pertaining to a telemedicine system for patients with diabetes. There is a verbatim transcript on the left-hand side and notes on the right-hand side. The transcript reflects the first part of the testing situation in which demographic data is collected. Although not in evidence on this slide, such analysis may include a description of the user's goals, actions, and problems. On this slide, the user was performing a task in which she was asked to upload her blood pressure and blood glucose readings to a central computer located in the hospital. The patient is at her home. In this case, she is able to execute the task without any difficulty. This slide has two excerpts of a microanalysis. This is a very fine-grained analysis with moment-by-moment coding. For example, there is an analysis of every single action, verbalizations, changes in body position, and hand gestures. Basic analysis requires about 3 hours of analysis for every hour of recording. A macro analysis may necessitate as much as a 10-to-1 ratio, and a microanalysis would require as much as a 50-to-1 ratio. In most cases, a basic analysis will suffice for usability testing. There may be instances in which singling out certain tasks for further scrutiny in the form of a macroanalysis is warranted. The reason for illustrating the 3 levels of analysis is to understand the ways in which they differ and how one can explore a problem in increasingly greater levels of detail. Triangulation is a strategy in which you use more than one method to derive conclusions about system performance. Triangulation provides different perspectives and corroboration of findings across techniques. For example, it can be quite useful to survey a large number of users and conduct usability testing with a much smaller group, e.g. 5 or 6 users. The use of multiple methods also leads to more rigorous and defensible findings. This concludes Lecture B of Usability and Human Factors Usability Evaluation Methods. The value of usability evaluations in healthcare contexts has been well established. As discussed previously, the consequences of not conducting usability evaluations has also been well documented. There are a range of methods that are commonly used. They vary in terms of their advantages and disadvantages. Some are easier to learn, and others necessitate greater expertise and a greater time commitment. The lectures illustrated how to employ some of these methods, including the cognitive walkthrough and usability testing.